Okay, welcome back to CSE 132C database system implementation. Today, it's a pleasure to have with us Drew Banin. I hope it's pronounced correct, Banin, right?
Yeah, sure. Better, yeah.
He's a co-founder of DBT Labs now. And this is a tool that I've heard a lot about for pioneering this practice of analytics engineering. And so Drew is the co-founder and former chief product officer at DBT Labs. DBT is used by over 9,000 companies every week to organize, catalog, and distill knowledge in their data warehouses. And Drew works with open source maintainers, contributors, and users to build DBT and apparently strike fear in the hearts of database optimizers. So I'm curious to hear what that means, Drew.
Sure. Yeah, we'll talk about it a little bit. Thanks for the introduction, and it is great to be here.
Okay.
I was saying right when we joined, like, I was in this kind of class not so long ago. It doesn't feel like that long. Anyway.
So do you prefer do you prefer questions during the talk, interrupt and kind of ask, pause in the middle and answer, or do you want to wait till the end?
Yeah, no, I mean, I would love it if folks, if you have questions, like drop them in the chat. Feel free to unmute and shout it out. Whatever works for you all works for me.
Okay.
I sat through a bunch of lectures kind of like this where it ended up like not being super useful to me, and I want this to be as useful as possible to all of you. So if you have questions and it takes us in a funny, interesting direction, like, I just want this to be useful. So please feel free to shout them out or drop them in the chat. We can talk about whatever's on your minds.
Sounds good. Okay, let's get started. I will also monitor the chat in case there are questions there. So all yours.
Okay, perfect. Yeah, so my name's Drew. I'm one of the co-founders at DBT Labs. We started building open source software called DBT about 6 years ago, a little bit more than that at this point. Since then, we've sort of grown. We're a technology startup. We have a proprietary product called DBT Cloud. And I would be excited to talk about like that journey and kind of the company if that's interesting to anyone towards the end. What I sort of want to ground this whole presentation in is like the work that goes into doing analytics effectively. Of course, databases are a really big part of that, but it turns out that a lot of analytics and business intelligence is like effectively counting things, and it turns out that the really hard thing about all of it is knowing what things are, or what we mean when we say certain things. So I kind of want to ground this in like the human parts and the collaborative parts of analytics, but we will go kind of deep into what DBT is, how it works, how it does its thing. That's kind of the run of show here. So right, I'm Drew. I'm in Philadelphia right now and make DBT. If anyone's on Twitter, I'm at Drew Banin. Feel free. So working in data has kind of ruined the whole news process for me. When I see news headlines, I always think about the data team that's kind of behind the headline in some way. A lot of times these data teams are like understaffed or underappreciated. And so here's a headline from a little bit ago. When I read a headline like this, I think about the data team who's sort of getting requirements from stakeholders and say, we're going to do this product launch. We need data. They do a bunch of work. And so they're doing this work, and like suddenly things start shifting, and the thing that was prioritized isn't maybe going to be a priority anymore. And at the end of it, the business like scraps this new idea, this new concept. And so they have to like throw away all their code and, start on the next thing. It's kind of an uphill battle, right? I don't want to make it seem like I'm picking on Facebook here, but this to me is like one of the more misapplications of data that I've seen, at least recently. For anyone who hasn't like heard about this pivot to video thing, a lot of news organizations sort of got this data from Facebook that said people really interact with video content a lot more than written content. And so it led to this pivot to video where news outlets started creating a lot more video content and like started shrinking their journalism teams, right? So it turns out Facebook's reporting on engagement was incorrect. And specifically, they had average duration of video viewed. And the error was that Facebook only counted views that were longer than 3 seconds in the average. So it discounted all of the views that might have been like 0 seconds or close to 0 seconds. And of course, those data points would pull down the average. So the entire like journalism industry changed in a meaningful way because of like invalid reporting on data that Facebook did and sort of broadcast it out to their customers, like advertising customers, I guess. So it turns out business logic is hard, like average video views, right? Like what's a view? That's kind of a hard thing to pin down. A lot of companies think about a metric like weekly active users. This is sort of how companies measure activity if it's kind of growing over time. In practice, even knowing what a user is can be kind of challenging. Like I could come to your website on my laptop, and then I could also come to your website on my phone. Am I two different users? Am I one user? Like kind of distilling that can be a little bit of a challenge. These last two are like a little bit funnier. Like, is a burrito a sandwich? Turns out that has like tax implications, right? Like sandwiches are taxed differently than non-sandwich food items. So I feel like I heard somewhere that burritos are, for tax reasons, categorized as sandwiches, but I might be making that up. This last one is a dog bed and mattress is like a true experience that I had in the early days of our company when we were a consultancy. We worked with a company that sold mattresses online. And so they kind of had two numbers that they looked at. They looked at mattress sales and they looked at accessory sales. And they had these two dashboards with different numbers, and we couldn't figure out what the discrepancy was. And it turns out that this company sold dog beds. And in one of the reports, it was categorized as mattress. In the other report, it was categorized as an accessory. So like, is a dog bed a mattress? Like there's no database that can tell you that. That's like a decision that people need to make. And the data analysts need to sort of like understand that decision and account for it. So it turns out DBT is a pretty good way to manage business logic and changes to business logic over time. We're going to do a little bit of a deep dive into how DBT does its thing. We're going to talk about data warehouses and kind of like the tools of the trade that analysts or analytics engineers are using these days to do analytics at scale. So we're going to start with some letters, ETL and ELT. We're going to keep this part kind of high level, but it's a deep well if you're interested in this kind of thing. The old school approach was called ETL. And so those letters stand for extract, transform, and then load. In the ETL world, you're taking data from different data sources, like your application database, or for a lot of companies, there's like web software that you use, like Salesforce or payment systems or other services that have data that you want to sort of centralize. So you extract that data, you then transform it kind of in this stream, and you load that resulting transformed data into the data warehouse. So this is how it worked for a pretty long time. It's called ETL. The newer school approach is called ELT, which is kind of the same steps, but in a different order. So here you have a very small, like discrete process that just extracts and loads data from these sources into a centralized data warehouse. And then you have this sort of out of band process that continually transforms that data as it arrives. There's a lot of benefits to doing it in the ELT way. A big one is flexibility. Like you can change the way that you transform data, and you don't need to like replay it, like re-extract it from the source. The data is kind of already in your data warehouse. I guess quickly at this point, I want to talk a little bit about data warehouses. Is this a concept that has sort of come up in this course, like a data warehouse versus a transactional database?
We will be talking about parallel data flow systems actually after this. So it's a great segue to this, but the students are aware of database systems, parallel database systems, transaction management and stuff. So this is like an advanced database systems implementation class. So I think, yeah, people are very familiar with SQL and database system architectures.
Perfect. Okay, so the primer until the next lecture, I guess, is these data warehouses, we would call them, are databases. You know, it's a regular database. You query it with SQL, got tables. But the big distinction is that they tend to store data in columns instead of in rows. The benefit is that you can have faster table scans, but and aggregations and sort of analytics queries. But these tend to be a lot slower for transactional workloads, like inserting a record or deleting a record. So you wouldn't want to build an application on top of a data warehouse, but you also wouldn't want to like do analytics at scale on top of something like Postgres or MySQL, because at some point, like you don't want to table scan 1 billion records on Postgres. It's like not going to be happy about it.
Oh, yes.
And there's more.
Students are familiar with the column stores. So we covered that in class, row stores, column stores, operator implementations on those. So
awesome. Okay. So yeah, these warehouses are columnar parallel data stores. Perfect. So yeah, you throw all your data into the warehouse in this ELT paradigm, and then you can transform it. The benefit is like your business logic will change over time as your business or product evolves. And then you have sort of the flexibility to transform that data differently and apply different rules, as your business and needs change. So these are some of the warehouses out there. There's in fact like a lot more beyond this list. Databricks would probably call themselves a data lake house, which we can dig into if anyone's interested or curious. But probably what we're going to do is we're going to bring the computation to the data that lives in the warehouse. We're not going to extract this data from the warehouse, transform it, and put it back in. We're going to issue queries to the warehouse, like create table, insert, delete, merge, queries like that, that we'll look at a little bit later, to get the warehouse to reshape the data that's already kind of inside of the warehouse. Cool. So right, DBT, the core part is open source. With DBT, you can build what we call data models in the data warehouse. These data models are kind of transformations over source data. When we think about a transformation, that could be like, it's SQL queries. It's basically SQL Select Statements, but you're filtering invalid records, you're joining tables together, you're aggregating data to kind of create new data sets. We call these things data models. Some of the goals for DBT, like we want these models to be testable. We want them to be readily documented so that people can know what they do and how they work. These things are all version controlled. And crucially, DBT models can depend on other DBT models. And so you end up getting a sort of graph or DAG of this execution logic of how data flows from like these source tables into your modeled destination tables. So DBT itself is not a database. It relies on databases to do this transformation of data. And it's open source. If you want to check out how it works, there's you can check out the code on GitHub.
So Drew, I have a quick question at this stage.
Yeah.
So the notion of transformations, what is the language for transformations? Can you support, for example, knowledge-based construction from flat text files, extract a relational database? Is that part of transformations? Because that is also part of ETL in some landscape. Is it like extraction of semi-structured data from video and images? Is that transformation? Or what is the data modality and universe of transformations you're dealing with here?
Yeah, pretty much. Here's the cool thing about DBT. Like, it does leverage the warehouse. So anything the warehouse can do, DBT can do, because DBT is just issuing SQL as a sort of orchestrator to the warehouse. We'll like take a look at that a little bit later. But in practice, data warehouses like Snowflake, Redshift, BigQuery don't work with like media. It's either structured or semi-structured like JSON data. And the transformations that you want to do are sort of, we'll actually look at an example here of this DAG. So yeah, this is a good one. This is a DAG of transformations. These green tables, or these green nodes in the DAG are source tables. So these are things that are loaded by some sort of data loading tool. And you see here, it's like, we're looking at Stripe and QuickBooks, and I think we can actually zoom in on this part, right? So we take data out of QuickBooks. If you're not familiar, QuickBooks is like managing your books for the business. It's like how we know how much money we're making and how much money we have in the bank, things like that. QuickBooks has built-in reporting, but it turns out like our business changed over time. And so we started with a single QuickBooks account when we were, this isn't important, but we were an LLC, we were a limited liability company. We were growing, we had reasons to change to what's called a C Corp, and we all of a sudden became DBT Labs Incorporated. So it turns out you can't just take a QuickBooks account and switch from an LLC to a C Corp, you actually need a new QuickBooks account. And now we have this problem, which is like our finance data was spread across 2 different QuickBooks accounts, and we couldn't easily reconcile like how much money do we have in the bank, or how much are we paying employees, and how does that relate to how much money we have in the bank, and what's our revenue, right? Like these are important things to know if you're running a business, but it was actually pretty hard for us to understand. So this is like a great use case for DBT. What we can do is take these different data sets from different sources, and it's actually shown here like visually. We can kind of join these things together. So up here, it's the LLC invoices, and then here's the C Corp or incorporated invoices. And then we can just more or less think of it as like a union, like an append, to get a unified list of invoices across both like our LLC days and our incorporated days. So this tends to be the kind of stuff that people do with DBT. It's not so much like, oh, let me say it's like mostly structured and semi-structured data that people analyze.
Okay, got it. So within the structured and semi-structured space, are you focused primarily on the SQL DML with select from where, or do you also handle updates, inserts, deletes?
Yeah, great question. And I forgot about that part. So today, DBT is all SQL. Okay. And I guess what I'd say is like, there are lots of ways to build, okay, look, these blue nodes in the DAG, these are tables that they're like derived tables that DBT builds from your data sources. And so we'll see like DBT basically runs create table as with a select query to build that table. So it's all select statements. But the cool thing is, as a user, you don't write a delete or insert or merge or anything like that. You write a select statement, and it's DBT's job to take that select statement, apply DDL and DML to it, and then sort of give you this table back. And we have a couple slides that like go deeper on this part in particular.
Okay, sounds fascinating. Looking forward to it.
Cool. So yeah, big takeaways here. DBT is a DAG. Load data into the warehouse however you can, and then with DBT you can start combining data sets, joining things, filtering, grouping, whatever you need. And this is like our pipeline really to generate a list of transactions across. Reality is even more complicated than it seems. Like some transactions are in Stripe, some are in 2 different QuickBooks accounts. Like we want to merge all these things together and get a single table in the database called fact transactions. If anyone's interested in this kind of thing, like why is it called FCT fact transactions? If you can see this at the end, I know it's small. This comes from like the Kimball data modeling paradigm. And there's a couple of different data modeling paradigms out there. So that's an interesting thing we could come back to later if anyone's curious. Okay, so here's the big picture. Cylinder in the middle is the data warehouse. You've got data loaders loading raw data into, like a schema, just say, or like a sort of logical database. It's then DBT's job to take that source raw data and transform it into modeled data that sort of reflects all of your business logic. And then you can plug in BI or like business intelligence, analytics, data science tools and query that model data so that you benefit from these abstractions and sort of reuse this business logic. The alternative is like putting your business logic into every tool that you use and kind of copying and pasting, and then your logic starts to skew across different tools. So why build DBT? This was really striking to us. Like I got a computer science degree. We were talking at the top about my experiences using Git at undergrad, but people that build applications tend to version control their code. They do code reviews in something like GitHub. They document their code. They write automated tests. They have CI/CD processes for deploying that code. In 2016, when we got started building DBT, it was like chaos. It was like people would run these arbitrary queries. They'd create tables in the warehouse, and the tables would be called like, customers v2 do not use or something like that. It's like, where did this come from? Who created it? What was the logic that was used to create this derived table? So it was like the Wild West, right? Like there were no dev and staging and production environments. Everyone just worked in prod for the most part. It was hard to write documentation for these things because they weren't like well-defined. It was all kind of ad hoc. So you frequently need to like ask someone like, hey, how is this table defined? What's the logic in here? And really hard to test. Like a lot of it was kind of spot checking. So you'd write a bunch of SQL, you'd run it to create a new table. And for testing, you'd like, I don't know, select star from that table and see if it looks right. It could be really hard to sort of make sure that the table matches your expectations. We'll talk a little bit more about testing later. So our goal for DBT was to take all these best practices from application software engineering and bring them to the field of analytics. And it sort of birthed this new role and sort of title that we call the analytics engineer. So it's all the context about the business that an analyst should have, with the sort of software engineering rigor of an application developer. So in DBT, you can version control these SQL transformations with Git. They're just select statements, so you can pretty easily version control them. DBT helps create these sandbox development environments so that you and I can be developing our data models at the same time and not like stepping on each other's toes. There's built-in support for testing your data sets and making sure they meet your expectations. And you can do really mature work to like test and deploy your code when you merge pull requests in GitHub or GitLab or something like that. So it ends up being like a lot of the tenets of software engineering just translated into the analytics realm. So we did say like DBT, at least today, works exclusively with SQL. We can talk about how that might change in the future a little bit later. SQL's been around for, I don't know, 45 years, 50 years. Every analyst out there can either learn SQL if they don't know it, or probably they picked it up at a previous role. It's a much simpler language than something like Python. And so it's, sort of reasonable to ask a data analyst to learn SQL in a way that like, if you ask them to go learn Python, that might take a little bit longer. SQL is really powerful, especially on these data warehouses. There are kind of complex SQL constructs like window functions or these kind of powerful aggregations and user-defined functions that sort of all together mean that like SQL isn't going to hold anyone back. Like whatever business logic you need to express, you can express with SQL. And some of the other big benefits of using SQL are that you connect to a data warehouse as a client when you run SQL. So you might have terabytes of data in a data warehouse. It's not really great or feasible to download, terabytes of data and transform it on your computer, with Python and pandas or something like that, if you're familiar. Instead, what you want to do is bring the computation to the data by kind of sending SQL queries. So for a data intensive task like transformation, it makes a lot more sense to offload the processing to the warehouse with SQL than to download the data and process it, on your machine. Finally, it's like SQL, it's code, so you can diff it, you can version control it. This is sort of different than like drag and drop experiences that sometimes people have used for modeling data. The drag and drop experience is like approachable, like even more so than writing code, but it's hard to diff, a drag and drop diagram. It's hard to version control it and understand why did this change and who changed it. Whereas SQL, you can do that. So let's get into sort of like the meat of it. How does DBT work? In DBT, you write SQL select statements. So this thing that we're looking at here, this select query, is basically a DBT model. We're going to select a user ID, an aggregation over like the number of orders and the lifetime order total for each particular user. The astute observers here will note that this is not SQL that you can run against most databases. This part in curly brackets is a templating language called Jinja. And it's like relatively popular in the Python world. Maybe you've seen it if you've ever tried to build a website with something like Django or Flask before. But the cool thing is you can use this templating language to sort of extend SQL and sort of almost in a way like pre-process your SQL. So as a DBT user, you write the select statement, use a little bit of Jinja. DBT will then compile this Jinja to pure SQL. So here we saw, before it was this ref function, and we're saying, I want to select from another model that's called orders. When DBT goes to run this data model, it will replace that ref function with its return value, which in this case is analytics.orders. This ends up being one of the most powerful parts of DBT for reasons that like aren't immediately obvious, but that we'll talk about in a couple of slides. So now you've got a select query, you could run this against the database. And if you do, you'll get a table of data back. But in DBT, we don't want to get a table of data back. We just want to create a new table in the warehouse. And so you can use DDL and DML to, on the data warehouses that DBT supports, go ahead and create this table, in this case called analytics.users, where analytics is the schema, users is the table name. And now you've sort of orchestrated the process in which the warehouse will create a new table based on your definition. So this ends up being the model code, the select statement, and the create table part is sort of the boilerplate logic that dbt will inject into this query for you. Cool. So here's kind of the full example. We talked about the ref function, but we didn't really say what it does. This ends up being like kind of the magical part of dbt. Here we're looking at the user's model. And when we ref this orders function, dbt can detect that we're selecting data out of one model and kind of into another. And so dbt can build this DAG, this edge between the two nodes, so that it understands, first I must build the orders model, and then I can build the user's model. If you did this in the opposite order, you'd get like incorrect or sort of invalid results. So this is how dbt builds the DAG that we looked at a little bit earlier. It's via this ref or like reference function. So this is kind of all of it put together. And I guess maybe this could be a good place to checkpoint. Does anyone have any like questions or thoughts at this point? How dbt does its thing?
Questions from the audience? So, well, they're thinking I can ask a question here. So this is cool. So this seems like dbt allows you to do a meta level kind of injection of concepts, business concepts that could be, say, from a knowledge ontology, instead of actually referencing the schema literals from your database schema. So here, there's orders within that quotes in that ref thing. Orders is like a general concept, but then you have to rewrite it to analytics.orders. Is that fair to say? Like dbt will allow you to more easily navigate the complex schemas that exist in these enterprise warehouses?
Yeah, so it's exactly correct. And the benefits are twofold. So one is this is a logical reference to another sort of table or entity, whatever it is in the warehouse. The second benefit is that by avoiding pointing to a concrete table like analytics.orders, we can interpolate this to point to different schemas. So if I'm running it, I can point to drew.orders. And if you're running it, you could point to professor.orders. It means that we can both have our own kind of sandboxes where when we do a dbt run, and we'll see this part later, we can build these models into totally separate namespaces so that I can be developing code in a branch locally and you can be developing code in a branch locally. And we're not like overwriting each other's tables. And even more importantly, like we're definitely not overwriting the production tables that are powering data science and analytics and BI. Like that's in its own production schema with lockdown permissions. But you and I can do whatever we want in our own development sandboxes.
I see. Okay, very cool. So what do you think was the world before this sort of dereferencing based injection of schema elements came into being? So data analysts, like you said, SQL has been around for 40 years, Oracle, Microsoft, IBM, they've had these kind of tools for SQL IDEs, schema navigation, but this sort of seems new, this sort of dereferencing with automated injection based on an ontology. Why do you think this was not there before?
Yeah, so I think this did exist before. And what would happen is like companies or data teams at companies would build a version of this in-house that they used and were never really happy with because it was like a side project. It was like a developer productivity tool. But I don't think anyone had ever started a company around it and said, this is the only thing we're going to do. So in the early days of dbt, we saw a lot of people show up in the community and say like, yeah, we're excited to ditch this thing that we've got to work on nights and weekends and just use your thing instead.
Right.
So that, there was some version of this that existed, but I can tell you, like, I worked at a business intelligence company in college here in Philadelphia, and we had an internal data team that kind of did, I'd have to go way back. I guess we can do it. It felt like this. It was like chaos, what was happening in the database, because there just wasn't like, there weren't good workflows. There was no way to, everyone would want to version control code or open pull requests and do code review or automated test things. But like, we didn't have that framework. And so we just didn't do it. And it's sort of the equivalent of like, trying to build an application with your friends where you store all the source code in Dropbox. Like, can you do it? Yeah. Is it going to be awful? Like, yeah, it'll probably be awful. But it was functional. It just wasn't pleasant, and frequently it didn't work very well, you know?
That makes a lot of sense. Okay, this is very cool. So this systematizes some of those ad hoc practices that people did with, say, some scripting languages on top of SQL code, with procedural extensions or whatever. And this makes it more organized, auditable, and shareable across a team. So that's pretty cool. Okay.
Yeah, right on. Cool. Okay, let's
we can
keep
continue.
on.
Yes, I don't see any other
Yeah,
questions on the
good.
chat.
Cool. So here's kind of what it looks like in practice. And DBT, at least in the early days, was a command line application. So this is model code, orders roll up. And then when you do a DBT run, this is the command. What DBT will do is it'll look at your DAG of transformations. It's called a topological sort. So it'll find like the right order to run these models in based on the DAG ordering. And it will go ahead and build those SQL select statements in the warehouse using, create table as, or in this case, create view as statements. And by the end of the DBT run, you will have like all of these data models built out in your own sort of sandbox schema. So this is a sort of production run that we're looking at, and you can see it gets built into the ecom or e-commerce schema. So there's a lot of cool stuff in DBT, like it's just 4 threads. We can parallelize execution across the DAG, and there's a lot of tips and tricks like that, and kind of built into DBT. But this is the big idea, and this is more or less what it feels like to use DBT today. So let's talk a little bit about that DDL and DML and how DBT actually creates these objects in the data warehouse. There's 4 types of materializations. 4 types of materializations is what we call them. The DBT supports out of the box: view, table, incremental, and ephemeral. When we talk about a materialization, it is sort of this wrapping logic to take your select statement and actually turn it into a view or a table, or, as we'll see, more complex. There are more complex materializations. So incremental, as we'll see, we'll create a table, but it'll be a sort of upsert instead of a recreate process, and that's better for large data sets. And this last one, ephemeral, we'll talk about. That's a pretty cool materialization. So this ends up being like a lot of the secret sauce of DBT. And I say secret, but again, it's open source, so you can take a look at how it works if you're curious. But every data warehouse that DBT supports has its own quirks, and no 2 databases are alike in practice, especially when you want to go off and create a lot of objects in parallel in a transactionally consistent way. So let's dig into what those challenges feel like. Actually, before we do, these are kind of the goals for when DBT materializes models as tables or views. We want these materializations to be atomic. So, you don't want to leave the database in inconsistent state. Either the entire materialization completes or the entire thing fails, but you can't fail halfway through. We want these materializations to be idempotent. So if you run the same model twice and your data hasn't changed, you will get exactly the same output. This is really handy because it means that you can at any point just delete your data models in the development environment and rebuild them from scratch. There's no state that isn't kind of defined either in your source data or in your source code. We of course want these things to be correct, and that can be kind of challenging to do in some cases. To the extent possible, efficient. People don't want to wait for 30 minutes while a table builds. If there are ways that we can take advantage of database features to make these materializations run faster, then we like doing that when possible. And environment aware. We talked about this a little bit earlier. It's how I can have my own development workspace and you can have your own development workspace. And both of those are separate from the staging or production sort of schemas or environments. So the really cool thing, and I touched on this earlier, every model is a SQL select statement. So this is our same model from a little bit earlier. And again, we see this Jinja. And so this is kind of a directive that we give to DBT. We say, I want to materialize this select statement as a table in the warehouse. Or alternatively, you could put in the word view or incremental. There's a lot of other configurations you can supply. And so, with a 1-word change, you can swap this thing from being a table to a view or back again. This ends up being really powerful because it's a configuration change that results in a totally different object and lots of different SQL in the data warehouse. Oops. Okay, my mouse is kind of acting up. So let's take a look at the table materialization. And I guess I want to impress upon everyone how quirky some of these data warehouses are in practice, and why this particular thing is hard. So this is kind of a naive approach to transactionally, like, atomically and indefinitely creating a table in a data warehouse. You start the transaction, you drop the table if it exists, you create the table as, and then this is where your select statement goes. And the idea is the database should create that table based on your select statement definition. You commit the thing, if it succeeds, you get a table out, great. Okay, this will fail in terrible ways on every database that we took a look at earlier, like Redshift, Snowflake, BigQuery, for different reasons. It fails in like new and mysterious ways every time, which is what makes this work kind of fun. So on Redshift, you can't drop tables inside of a transaction. If you do, then queries that are selecting from the table that you're dropping will actually fail. So this is like your CEO is loading a dashboard, you run dbt and drop this table, your CEO's dashboard doesn't load because the table doesn't exist. There are ways around that, but that sort of is what happens. Database like Snowflake has transactions, but they don't really work the way you would expect a transaction to work. It turns out on Snowflake, DDL statements are auto-committed. So you start the transaction, after you run the drop table transaction, after you run the drop table statement, the transaction is committed, which is sort of not what you would expect this to do. And it means that we kind of break that atomic constraint that we're working with. We want to make sure that we never leave your database in an invalid state. And then BigQuery doesn't have transactions at all, so you're out of luck on that front. So what happens is dbt has this whole plugin system where we can generate totally different SQL for every database that it works with. People out in the dbt community can create their own adapters with their own SQL to work with other types of databases. In fact, one of them that came up recently that I saw in the syllabus for this course was DuckDB. So actually, I think the guy's name is Josh Wills. He's like a community member, friend of mine, and I think he made the DuckDB integration, which is kind of cool. Anyway, this is kind of what you have to do on Redshift. And this kind of thing isn't well documented. It was a lot of trial and error, I guess, for us to figure out how to do it safely. So what you do here is you begin the transaction, you create a temporary table. So you use this temp suffix. It's actually a permanent table, but you give it a temporary name just to identify it. And then you use your model select statement as before. Then what you do is you take your existing table, if it exists, and you rename it with a backup suffix. So you've kind of moved this table out of the way. Now, before we would just drop that table inside of the transaction, that would have the effect of canceling queries that are in flight hitting that table. By altering it, the database Redshift is able to still resolve the query, even though it's at a different location in the warehouse. Finally, you take your temp table. I shouldn't say finally. Next, you take your temp table, you rename it to drop the temporary suffix. So you kind of move this new table into place where you want it to be in the database, and then you commit that. So at this point, you have replaced the existing table with a new table, but you haven't yet dropped the old one. So then what you do is outside of the transaction, you can drop that backup table in order to make sure that you're not taking up disk space that you don't need and not leaving a bunch of mess kind of floating around in the database that doesn't need to be there. So this is the anatomy, basically, of a materialization to build a table for Redshift in dbt. Pretty cool. Now, not all databases do it the same way. It turns out Snowflake and BigQuery are actually a lot nicer on this front. They have this sort of SQL extension, create or replace. So this is actually an atomic way to replace a table with another table. But even this is sort of misleading because this query will fail. Oh, you know what? This is temp, but it shouldn't say temp. You would just create the permanent table. Yeah, this query would actually fail if the thing you're trying to replace is a view and not a table. So there's logic to account for that, but really just want to call out the variance of play here across different databases. Let's talk about a more interesting example. You can recreate a table as we just saw. You might want to do that when new data arrives. So every day, if you're loading new data, you want to rebuild this table with all of the data that came into the warehouse in the last 24 hours. If you have a lot of data, say terabytes of data sitting around in Snowflake, it can be really slow and expensive to recreate that entire table especially when you have 10 years of data. Like, you don't need to refresh the data that you loaded 10 years ago. It's like not going to change. So instead, what you can do is just sort of refresh the data from the last 7 days or since the last time DBT ran or something like that. So we want to select new data from our source tables. We want to transform that new data, and we want to upsert these data points. So like update plus insert into the destination table. So it's just more efficient, it's faster. You wait less time looking at a terminal, waiting for your query to complete. So here's broadly what this looks like. This time, we're going to create a true temporary table with whatever our model select statement logic is. And so in your select statement here, you'd actually filter the data set. So you're not going to look at 10 years, 2 terabytes of data. You're only going to consider data from the past 7 days, something like that. So it's a subset. It's the incremental data set you want to upsert. What you can do then is delete from your destination table inside of this transaction where there's a record in the table. So the ID is in this incremental temporary table. So we're going to delete records that are kind of matched in our incremental temporary table. And we do this insert. So this effectively does both an update and an insert at the same time. The reason it's a delete is because most data warehouses implement updates as a delete plus an insert. So we actually save like one of these insert queries by doing a delete and insert instead of an update and an insert. That's like kind of deep in the weeds of how these databases tend to work. But this is sort of like how you would atomically, incrementally update a table on a database like Redshift. So again, other databases make it easier. BigQuery and Snowflake have a SQL, I think, extension. I don't think this is like in the SQL spec, but I could be wrong about that. It's called the merge function. And so merge is, again, an atomic way to do this multi-step operation. So you can merge into your destination table, merge into your destination table from your sort of temporary table. And then there's these different clauses you can apply. So when not matched, this is like, there's a new data point that needs to be inserted. So when not matched, you would insert. And when it is matched, then it means that you have a data point in your destination table that's also present in your sort of incremental temporary table. And so you update the destination table with whatever transform data you have from your temporary incremental table. So again, deep dives into kind of how DBT does its thing. Assuming that you write all this logic to go off and model your data with table models and incremental models and views, there's like another step that you want to do to make sure that the logic that you're writing in SQL is correct. So here's one example from like our actual DBT project. We track all of the commits to this DBT repository because we want to understand what percentage of commits are coming from our team versus, like out in the community. So we take this data from GitHub, we extract it and load it into Snowflake. We transform that data using DBT, and we report out on it internally. So this is a YAML file that we use to both document, although it's not shown here, and test the columns in these different tables. So here we have a table called stage GitHub commits. If we have time, we could talk more about staging models, but it's kind of like that fact model from before, just like a nomenclature thing. So there's a column in this table called SHA. It's like your Git SHA. And what we want to make sure that we do is check that there are no duplicated or null Git SHAs in this GitHub commits table, because a Git commit can never be null and it should never be repeated. If it turns out that one of these commits is null, or if it is repeated, if it's not unique, then it means that like either we did a bad job of loading the data and we errantly have duplicates in our tables, or it means that our logic was incorrect and we somehow created duplicates or null values where we don't expect them. So you want to test this stuff, because if you have a really complex network of different DBT models that depend on each other, it can be pretty easy to make a change in one place that feels innocuous that actually has an unintended consequence on some other model kind of downstream in the DBT DAG. So by defining these tests, it means that you can kind of run an automated test, when you open a pull request or as you're developing code, to make sure that the code that you're writing is doing the thing it's supposed to do, and that you're not breaking something that previously worked. So testing is a little bit different than like unit testing in software engineering. What we're really doing with these tests is we're codifying our assumptions about the data. So an assumption is like git commit SHAs are unique and should never be null. That's like an assumption that I'm making about the data. If that is not true at any point, then it means my analyses on that data are going to be incorrect. You know, maybe I'm relying on it to be unique for a query. So it's worth thinking about like, how can these assumptions not hold? Like, how can they be broken? So one example is code changes. You know, like you introduced a bug by accident in code change. Like that happens all the time. Tests can help catch that before they get merged. What also tends to happen though, that's kind of unique in the data space, is that you're sort of reliant on data that comes from other systems. So maybe GitHub's API has a bug and the data that we're loading from GitHub is duplicated, or the git commit SHAs are showing up as null. Like we actually don't have any control over that. The best that we can do is know about it. So what people tend to do is they run these tests kind of nightly, just as an example. And every night you can check and make sure, like, does all of my data meet my assumptions? And if for some reason there's invalid data or your tests fail, you know, you come into work the next morning and you get an email alert about it, and then you can go and figure out what went wrong and what to do about it.
Drew, quick question.
Yeah.
Great. Sorry to interrupt. So this testing thing, the traditional practice has been to add integrity constraints to your database definitions, like the uniqueness and the not null and values. You can, there's a rich language of integrity constraints you can express. You can create triggers and stuff like that. Why do you think something of this sort is a better fit in this environment? Is it because they don't know all the integrity constraints to declare upfront? And so this thing allows them to, in a more fluid manner, add tests later on?
Sure. So we ended up taking all of the integrity constraints, or not all, but some of the common integrity constraints you get on Postgres, and kind of rewriting them in this testing framework. None of the data warehouses that we've talked about support integrity constraints. So you can't put uniqueness constraints on Snowflake or Redshift. Actually, it's wild. So on Redshift is a fork of like Postgres 8.2 or something like that. And so you can specify integrity constraints, but they're not validated. So you could have duplicates in a unique column. But here's the wild thing. If the query planner uses these constraints to optimize the query. And so what will happen is if you have a unique column, but there are duplicate values, you will get the wrong answer back for your query. You will get an incorrect value back. So we tell people, we're like, do not use constraints. Like, yes, it might make queries a little bit faster on something like Redshift, but you really don't want to get wrong answers. And I think it ends up being like a columnar database kind of thing. These data warehouses are built to ingest data as quickly as possible. I also think that practically, they're different considerations than a transactional database. So you actually want to like keep the data that you get, even if it's incorrect, because sometimes it's the data that you have, right? Like, okay, our source data said this column would be unique, but it's not unique. There's two different IDs. As an analyst, you need to reconcile that. I'm sorry, I'm like speaking too quickly. You might have two records that have the same primary key, but actually like different values in the row, right? Like it is then your job as an analyst to figure out like what to do about that. And you actually don't want the database to fail the data loading process or reject one of the records, right? You want to get the data so that you can then transform it. And this frequently is the work that people do with DBT. It's like cleaning up errant or kind of junk data, you know?
That makes sense. So basically it's inspired by this data lake style worldview where you just get the data in and then you apply the test later rather than ask the system to enforce at entry point time. Okay, that makes sense. And so this integrity constraints that you support in these tests, does it subsume everything that the traditional database systems used to do, RDBMSs used to do?
Yeah, so by default, we can test for uniqueness, nullity, foreign key relationships, and like an enumeration of acceptable values.
Okay.
The really cool thing about DBT is that you can extend these tests with your own logic. So when we write a uniqueness test, well, a better example is like the not null test. Well, basically, select, column from table where column is null. And so what you do is you get all the records where the constraint does not hold. So if you get 10 records back that have null values, then you say, okay, you've got 10, we expected 0, that's a test failure. So you can write your own query and then run that as a data test.
What about range predicates, like predicates?
Yeah. So
those can also be specified in this YAML-based config.
Sure. Well, it ends up being, let me show you. We'll jump in the source code. Can you still see my screen okay?
Yes.
So it ends up coming back to, oh, this is going to be gross. I'm sorry. Macros, I wonder if it's in here, generic test SQL. Okay, so this is the not null test, and there's some stuff in here that's not going to make a lot of sense, but it doesn't matter that much. If you just focus on this part, it's like select a column from a model where the column name is null. And if you kind of register the test in this way, so it's like test not null, then you can reference this not null test. And so this is built into DBT, but as a user, you can write your own, what's called a macro, with whatever SQL logic you want, and then we can run that logic on your tables and tell you if like your assumptions don't hold.
Got it. That's great. So it's like user-defined tests, and you can specify it in full SQL.
Yep, exactly.
Thank you.
And so, I mean, going even further, like, check this out. This ends up being really cool. DBT has a built-in like package manager. So this is a package that we call DBT utils, and this is sort of adjacent to DBT. But if we look at this, it's like a list of tests that people out in the community have written. So we can look at, here's a fun one. I don't know if this is going to be really gross to look at or not. Yeah, this is a much bigger, well, it's not that much bigger. Maybe I shouldn't have pulled this query up, to be honest. What's this doing?
As a group,
yeah. So the idea is like, okay, this is a unique combination of columns. So it should say like column A and column B together should be unique, but you can have duplicates in A and duplicates in B. So this is like a more complex test, and okay, it took me a couple seconds to parse it, but probably it's a select statement,
Sounds good.
Cool. So we're running a little bit low on time. I'm going to kind of breeze through here. We looked at macros. Big takeaway is like, you don't want to copy and paste code. So instead you can stick it in a macro, kind of reuse it. Here's an example of that, like cents to dollars. Basically it's divide by 100, but when you start thinking about like numeric precision, there could be reasons to want to use something more complicated. Oops, oh my goodness. So here's an example of that. You can reference this Jinja macro in your select statement, and it will expand to the kind of bigger SQL query. This is great for code reuse and to make sure that you're not copying and pasting the logic everywhere. Documentation is really important. If you're building these data models, you want people to understand which data models exist, how to use them, caveats, constraints, best practices. So DBT can kind of build this website for you, and you can visualize the DAG. This is where our DAG picture from the beginning of the presentation came from. And you can search, and so you can say, I care about subscriptions or revenue or customers, and you can find the relevant tables and sort of details about their columns and how to query them. As we think about the future, there's some stuff that I find personally really interesting that we're going to kind of explore over the next year or so. We say that SQL is code, and people write style guides for how to write SQL so that everyone's code looks consistent. I think it'd be really cool to be able to link that code and kind of validate that it matches your style guide. There's a lot more that we can do if we can like parse SQL. That's kind of the next frontier for me. And we're thinking about DBT models written in Python. This ends up being like kind of a different paradigm shift. There's a lot to say about that, but it's a pretty cool innovation, I think. Broadly, we're working with a lot of different databases out there to build really good DBT integrations. So Materialize, Firebolt, DuckDB are some of the ones that have come to fruition recently. But there's others. There's like ClickHouse. It seems kind of cool. There's more beyond that. We want DBT to work with all of them. And in particular, like I'll just tell you, I think Materialize is a really, really cool database. It's not really a transactional database. It's not really a data warehouse, but it's all built on streaming. So basically everything is more or less a materialized view, and you pipe data in and it sort of ripples through the whole database, and then you can hook it up to a queue on the other side. So I think Materialize is awesome. Totally worth looking into. It's a lot of cool stuff that we can do with metadata too, that I think we won't quite have time to dig into. So just to kind of round it out, DBT is all about managing these DAGs of transformations, using SQL, at least for today. It leverages data warehouses to create objects via these materializations. And I hope one of the takeaways here is that like the business logic is kind of at this point, with Snowflake and Redshift and BigQuery being so accessible, the hard part's getting the business logic right. So I think that the really big improvements in people's workflows and efficiencies are not going to come from like better and faster data warehouses, at least not in the near term. I think they're going to come from like more efficient ways to define data models and collaborate with other people across teams. And ultimately, the technology can facilitate this workflow, but to do data really well, it's like human beings talking to each other, deciding if dog beds are mattresses or not. The create table adds and transactional consistency, all that's really important. But I think the thing that we get most wrong in this industry is like not talking to each other and aligning around our shared definitions for data and what we mean when we say certain things like revenue or orders. That is in fact the end of my slides. Want to be very mindful of everyone's schedule, but I have like kind of a bunch of time to hang out if anyone does have questions or wants to talk more about this stuff.
Okay, thank you, Drew. Let's give Drew a round of applause. I see the reactions doesn't have an applause, so I'm just going to give you a coffee mug and then clap myself.
Cool.
Everyone's doing coffee mug. Great. Thank you, Drew. That was very enlightening and very exciting presentation. And also, I applaud the demo and the code walkthroughs. That's pretty bold.
That's funny.
Okay.
Yeah. No, thank you so much for having me. It was a pleasure. Yeah.
Yes. Questions from the audience. I have some more questions, but I'd like to give the audience a chance to. Students, any questions? Okay, so maybe I can get started while they are gathering their thoughts. One thing regarding the practice thing that you talked about, the exchanging information among data analysts regarding the workflow and stuff. How do you identify common practices to decide that this sort of templating or this sort of scripting is the most beneficial? How do you go about figuring out what capabilities are most beneficial for different data analysis use cases?
Yeah, when I think about this, it's been really cool to work at DBT Labs and see us grow from 20 people to 280 people, because I start to see the challenges that arise as you just have more people and teams like forming, and especially when you grow so quickly, like a lot of the people at our company are new. And so it ends up being like an information dissemination kind of problem. Like a team will build a new capability in the product that has some impact on revenue or product engagement. And unless that information makes it back to the data analyst, then like the numbers that you look at on a dashboard are not going to represent reality. So when I think about this type of collaboration, it really is less about like the code that you write, and it's a lot more about like the flow of information and how organizations like stay attuned to kind of what's happening in the org or in the product or whatever it is. This ends up being like the reason why we use data at all. It's like we want to understand what's happening. Like, are people using the product more or less? Are we making more or less money? And so if your organization can't transmit information about how the product is changing, then your data can't reflect out reality kind of back to you. You've broken this feedback loop. So a lot of it's like writing like updates to people, like having conversations, processes to make sure that people are kind of in the loop. It ends up being a lot more human than technological, I think, in practice.
Got it. Okay. How does the scripting that you're talking about and the testing stuff and also the documentation, how do they all work with BI dashboards and BI toolkits that are out there today, like Tableau and Power BI? Like, what is the relationship? Is this like a separate UI that they need to look at to understand the metadata and then kind of definitions of the views and the tables, and then look at Tableau for the results? Like, what is the relationship?
Yeah. So this is kind of changing. I will give you the up until now answer, and then I can talk a little bit about the future. The up until now answer is that you run DBT in this batch-based process, and you're just creating objects in the database. So like everyone who touches our Snowflake account internally knows that there's a table called dim customers. So the customers dimensions, right? It's called dim customers, and you don't really need to know exactly how that table is built. If you just want to see a list of customers, you can query it from Tableau, or we use Looker frequently. Whatever it is, you can write a SQL query in Datagraph, whatever you want. It's only when you want to kind of dig in and like find a new data set, or understand the details of like, how is this data set defined? Where did the data come from? And for the most part, you do need to kind of like go to that documentation website that I flashed it so quickly, but you can go there and find the table, and that works. But increasingly, we're seeing a lot of really cool integrations between different business intelligence tools and this metadata API that we have in dbt Cloud. And so the cool thing is the business intelligence tools are able to sort of present that interface to you and say, you wrote a query that references dim customers. Here's everything that we know about dim customers from dbt. So we can show you like, here's when this table was last built. Here's how fresh the source data is that powers this table, because that's something dbt knows about. And so you can kind of get that information in context, and you can say like, revenue looks way down. That looks like a problem. And then you see like data hasn't been loaded in 2 weeks, and you go, oh, okay, I understand. Like, that's why. So it's all about kind of bringing it together.
Fascinating. Sounds like exciting times ahead too.
Yeah.
Questions, audience? More questions? I see some students are still hanging around. So I do have one more pedagogical question, and I don't know what you think about this. So in the whole data integration space, the knowledge engineering kind of stuff from the 90s, people have done a bunch of work and research, but it's seldom taught in classes in universities because schemas are not open source. They are not available. Business critical schemas, enterprises seldom want to make it available to academics, to the research community. They are hidden away. In the analytics engineering space, how do you foresee that profession evolving? Like, do you think schools will be able to teach something of this sort without actually having use cases that they teach? I mean, SQL, of course, is very institutionalized. It's been taught for more than 3 decades now. But this intersection of software engineering practices and SQL you're talking about is very new. Even some of these software engineering practices themselves are new, CI/CD and stuff. They don't have as much history as SQL has. So where do you foresee academia's role in this space in the future? And how can people who work with these sorts of tools help ensure that the principles are actually covered in a pedagogically sound way?
It is such a fantastic question. I will just say, like, the reason I was so excited to come here and talk to this class is because I got very little of the sort of practical insight into what data means, out in the industry in undergrad. Certainly, like, I learned the fundamentals, but even the like graduate level classes, I think that they offered at my university, that I didn't do grad school, but they were really focused on a lot of the technology, which is important, but it doesn't really prepare you for the fact that, like, when you get a data science job, they say 80% of the job is data cleaning. And like, maybe you heard that headline, but like, what does it mean in practice? And like, what it means in practice is having a discussion about if dog beds are mattresses or not. I don't know how to do that exact thing in a pedagogically sound way, but I think that, okay, one of the really cool things about DBT and the analytics engineering kind of title and paradigm is that most of the people who do it are not computer science majors. Like, they weren't previously software engineers. Some are, like I was, but a lot of people were in marketing, or they were in finance, or customer support, or something like that. And they really understand the business. Like, they get what a marketing qualified lead is in a way that they don't really prepare you for in computer science class, So it's that understanding of the domain and the context, coupled with the technology, that we believe people can learn kind of on the job in a lot of cases. that makes the role so powerful. So, to me, it's, I think to me, it's twofold. One, it's like, I think it'd be good for people who go into careers in data engineering or data science to be a little bit more prepared for the practical nature of like, what does it feel like to do this? But also, I think it'd be really cool to expose people that don't have, I'll just say computer science backgrounds to, I was going to say STEM at first, but like one of the best analytics engineers I worked with was a chemistry major. So yeah, people that are in non-computer science backgrounds, like, hey, this is a really cool career path if you dig the domain and like data and want to, spend your time at the intersection of those two things. Now you did point out one thing, and I'm trying to find it quickly here, but I don't know that I'll find it right away. I can just share this link. So GitLab uses dbt, and they're very open about all the work that they do. So you can actually read through this page and find their entire guide to using dbt and best practices, their style guide. And somewhere in here, there's a link to their dbt documentation. So you can actually see every dbt model that powers like all of their analytics and reporting. And you could actually like see the schemas and the logic and kind of walk through it. And I think the actual repository is open source too. So stuff like this is pretty cool. GitLab's pretty extreme in terms of making things open source, but I thought it might be an interesting resource. Yeah.
Thank you for the link. That's excellent. I mean, this is sort of this whole thing being open source, and there is an open source community around it. I think that's certainly helpful. Increasingly, there is a lot of interest. So like practically every business school in the major universities teach database systems. They teach SQL. So we have a database, 3 database classes, I think, in the business school as well. They teach marketing, they teach customer analytics, business analytics, and so on. But I think there's this gap between database technology builders and people who teach it for computer science majors. And then there's data science, and then data science majors, and the kind of business majors. And so I think that gap we need to bridge. And it seems like now with the software engineering for database management and this notion of business concepts, bringing it closer to how data queries are actually specified, I think that should be an interesting avenue to look at. And these sorts of open source tools and these sorts of case studies are very, very useful. Thank you.
Yeah, no problem. Can I share one more quick anecdote? Because I think it's so interesting. My partner works at a hospital, and she's a pharmacist. So it's a special type of pharmacist that does specifically like infectious diseases and antibiotics, things like that. So doctors, when they want to prescribe an antibiotic, will sort of consult with her team to say like, they have this thing, we want to give this antibiotic, make sure that's okay. So her team is responsible for running these studies and seeing like, which antibiotics are we prescribing for different bacterial infections, and like how effective are they, and what's the dosing, and should we change it up? And so they have this database that's plugged into their like health records where they could conceivably run queries and see like, how often did we do this thing, like where we gave this dosing for this thing, and what was the clinical outcome? She learned SQL, like she learned how to write SQL so that she could pull this data herself. And then for reasons this is being recorded, maybe I've already said too much, like one day could no longer run SQL. And so the answer is you have to ask the data analyst, like, can you pull this data for me? So you have a question you want to answer. You ask the data analyst, like, help me get the data to answer this question. This data analyst is getting 100 requests from many different people every day. And so they're like, yeah, I'll get that to you. It'll be 6 weeks. So 6 weeks passed, they send you a CSV of data. It like isn't exactly what you were looking for because something got lost in communication, and you didn't get the data and they didn't get the domain context. So you've got the wrong thing. It took 6 weeks, and like the moment has passed, you're on another project. Like that thing went nowhere. So the thing that's so powerful about this, and sort of you talking about business school and SQL is what made me think about it. Like there's this concept of the citizen data scientist, I think they call it. And so like not everyone needs to be a data analyst, but just like the ability to access the data and then effectively query it, it's like a superpower for a lot of people, even if they're not like data people. Like they could just be people that use data. And I think that kind of thing is really inspiring when it works.
Thank you for sharing the anecdote. That's pretty cool.
No problem.
Okay, so that brings us to the end of the slot. Thank you again, Drew, for visiting us and for sharing all these insights and your exciting work all the best for the continued growth at DBT.
Yeah, thank you so much. It was a true pleasure, and I appreciate you having me on.
Okay, thank you to the audience for joining. Bye.
See you, everyone. Thanks.